Well, hello everybody, and welcome to the new video for Leetcode POTD. That's for 19th of January. And so here the question is maximum side length of a square with sum less than or equal to threshold. If you see clearly, in the last 5 or 6 days, the maximum questions were from the matrix, and we were need to find some square inside it. Okay, and especially I'm saying this because in future, let's say some new questions will be created, then they will be created on these types, the last 5 or 6 days, the POTD that has been coming. Okay, now first let's read the question, and then we will try to solve it. Given M cross N matrix with met and an integer threshold, return the maximum side length of a square with sum less than or equal to threshold, or return 0 if there is no such square. Okay, it says that okay, there is this matrix is given, and you have to find the maximum side of a square, and if the sum of the square elements, if all of the sum of these elements is less than the threshold. Let's say there are multiple squares that you can form in this matrix, that it can be of size 1, size 2, and the maximum size can be 3 only, because this side is 3 only. So let's say I made this as my square. Okay, so what is the total sum of all of the elements among this, that will be 12, 6, 18, and 18, 9, 27. Okay, this is 27, but what is the threshold here? It is given is, what is the threshold is 4 only, so it is not applicable, because the threshold is more, the sum that we have gotten is much more than the threshold. So what can we do? First very basic idea is that we will go to the each index. We will go each index I comma j. We will try to find all of type of squares, all of different type of sides that can be formed from this bottom top left point. Okay, let's make this ij as our top left. Okay, this is kind of rough diagram. Let's make a fair diagram. So first idea is, let's make this ij as our base, top left corner, and let go to the all of the different possible s from this ij, and let's find out the sum of all of the type of squares that are being formed. Now if you see clearly, this involves n cross m just to go to the I cross g. Then we are going to find the size, the sides. Then we are going to sides also, and then we are going to the whole array to just find the whole, sum of the all of the elements. Okay, so this will surely give you a TLE, that is time limit TLE, as in said in a code forces solutions. So what else can we do? Can we just pre-compute all of the sum of a rectangle? Can you think about this? So let me give you one example. Let's say somehow, let's say somehow, I just get to calculate that from each, let's name this matrix as DP, and let's say I have DP of 4 cross 4 DP. Yeah? Let's say I'm at this point, this is 2 cross 2, and if I'm here at DP 2 cross 2, it means it will cover all of the elements. It will take the sum of all elements, that are from 0 0 to 2 cross 2, यानी कि इस this whole square, or whole of this area, whatever the elements that are coming in inside this rectangle, or this square here, it is forming square, but we will take it as a rectangle for the generalizing part, that this value here will represent the sum of all of these values. Okay, now this can solve a lot of TLE problem a lot. Okay, so what we are going to do? Okay, let's take an example from this. So let's say I have a 3 cross 4 matrix, 3 cross 4 matrix, and this is my 3 cross 4 matrix, and it is converted into a DP matrix, which contains 0 0 0 and 0, because initial element are taking as 0, and we are taking the sum from, let's say, okay, if I'm taking the sum of all of the elements from this point, it will include 1 plus 2 plus 2 plus 1 plus 2 plus 1 plus 2, that means 6. So 6 is here. Okay, let's say I'm standing at for I'm looking all of the values that are for this index. Okay, so it will include 3 plus 3, 2 plus 2, and 1 plus 1. That makes 6 plus 6, 12, and 12 is here. So you can see that I have made this DP array very easily. Now let me give you one very basic example of how we can utilize this DP array properly, huh? So let's say we will first take our answer side as 1, because this is the minimum that we can get, Anna. And yes, okay, uh, we will take this as answer as 1 because we are expecting that we are first checking the squares of side length 1. Okay, and let's say if I am standing at some point, uh, let's say I'm standing at some point I cross j, let's say at this point. Okay, let's mark this index as I cross I comma j. Okay, so I will check in the the square that is formed of side length 1, and in the backward side, backward side means in the in this side, let's say I'm checking for answer is equal to 2. That means I will be checking, this is my I cross j, I comma j right now, and I will be checking for this square element, these square elements I will be checking. Hmm? If I just make it a bit darker, it will be, I'm checking for these elements. Okay, I will take the sum of this, and this four element. I will take the sum, and I will check if the sum is less than equal to threshold. And if it is less than equal to threshold, then I will increase my answer to 3. Why? Because we have got a minimum of 2 side. Now we will check for only for 3 side. Yes, and that's the very basic that's the basic example and the basic idea of this whole solution. Okay, now one more question here it is, here is how because this ij dp of I cross comma j will represent the solution or will represent the area of the part of this whole area. Hmm? And if I will make it in a better way, let's say I'm standing at here I comma j, so dp of ij will include all of these elements now, and that's an issue because we want only these four, we want only these four elements. So what else I can do is, let's say I will remove all of these area first. I can remove these all area, I can remove these all of areas, and then I can add this one part. Let's take a better explanation for this example. Whatever I have drawn, let's take a rectangle first so that we can understand properly. Yep, we are going for this part, and let's say okay, and okay, and let's draw now. Okay, and let's say I'm standing at point this. Okay, I'm I know that by one fact that, and I am checking for let's say this part. Okay, so this side will include my answer side, huh? Hmm. Now what I know is that my I will mark these areas, will mark some of these areas as different type. Let's say this 1 2 3 4. Okay, now I know for one thing for sure is that dp of I comma j will include the area of 1 plus 2 plus 3 plus 4, but I need only one. How can I remove these three part? So what else can I do? If I take the dp of this point, and dp of this point means dp of, because I'm moving upward, I will, it means I minus answer comma j, huh? So dp of I minus answer comma j includes which two areas, 3 plus 2. And similarly if I take the this part, that means I'm taking the I as the same part because we are moving in the leftward side, I doesn't change, but j is changing. So dp of I but j minus answer, what does it include? It includes area number 3 comma 4. And if I just subtract these two variables from dpij, what I will get? I will get 1 plus 3 plus 4 minus 3 minus 2 minus 3 minus 4. Okay, 2 4 2 4 cancel, minus 3 cancel, but 1 minus 3 also cancelled. So it now area is 1 minus 3. So if I will add this dp area, or this will be dp of I minus answer and j minus answer. Okay, so this will represent the area number 3. So if I will add this area to our solution, we will get only the area for 1 only. So what I have done is, let's say answer represents my side, my current side, okay, and dp of I comma j represents the area that is from 0 0 to all of the area from I till ij. Okay, so it will be the you know the sum of elements. The sum of elements will be dp of ij minus dp of I minus answer comma j minus dp of I but j minus answer, and add dp of I minus answer comma j minus answer. This will be the my final solution. This will be my checking of this square. Okay, and if somehow this sum of elements is less than equal to threshold, is less than equal to threshold that we have got, then what I will do, I will just increase my answer to 3. Why? Because it is sure that I can make a square of side 2. Now if we have checked in the previous example that I have made, that we will be iterating through all of the ij, then we will make all type of s side of squares, and then we will checking all of the whole of the sum of the all of the elements in this square. Now why are we checking all type of s when we have got a minimum side 2 as a square formed? So that's the logic, that's why I am increasing my answer to plus plus. Okay, and that's the only part which is interesting here in this solution. Okay, that why are we increasing the answer, how are you calculating the dp of ij, and how are we calculating the answer of this part, that is area number 1. Hmm? It is let's first look in on our code part, so that if somehow some point is there, I will explain it on my whiteboard or the blackboard only. So this is n, that is matrix dot size. M is the number of columns. I have already introduced a dp of values for 3 or 2, because I'm taking some extra values, because uh, m and n has maximum constraint of 300 only, just for the buffer size. Okay, so first let's take our answer is equal to 1. Why did we take answer is equal to 1? Because we are checking for the side length of 1, that if there are some squares of side length 1 or not. If there are, we will increase the answer to plus 1. So uh, first part is I we are circulating from 1 to n, and z is equal to 1 to m. Okay, and dp of iz means, that is first we are finding the sum till ij, first sum till ij. And what does it include? It includes dp of I minus j comma z, dp of I comma z minus 1 minus dp of I minus 1 z minus 1 plus matrix of. Okay, I will explain this part again, so that you can understand how this you know new dp is formed. Okay, so let's move to this part. Yep. Okay, let's say I'm standing at this part I comma j. Okay, I comma j. I want to check the answer for all of the elements that are included in till now, all of these elements. Okay, so what I will do is, I will dp of I comma j will will it will include, first it will include the matrix. It will include the matrix. We have taken this matrix of dp 1 to 2 point. Hmm. And this is our dp matrix. Okay, so what I will do is I will take dp of I minus 1 comma j. dp of I minus 1 comma j. Okay, what does it mean? I am filling out this value. dp of I minus 1 comma j means this value. This will include all of these, all of the sum of these all elements. Okay, okay, good. Plus dp of I comma j minus 1. This will include sum of all of the elements from till this part. Okay, this part is done, this part is done. And we will subtract this part because it is counted twice, as I explained earlier. So it will be dp of I minus 1 comma j minus 1. And if you see clearly, I haven't added this part of the matrix yet, and that is 2. So I will add matrix of I comma j, matrix of I comma j. And this is how I got this dp value 6 here. Hmm? And whenever I quote the value 6, I will check right now that if there is there is a square that is formed, that is being formed of side length of answer or not. If there is a square formed, then I will increase my answer, because for the next part, let's say for this part, this 12 part, I will I don't have to check for the, like 2 or 1. I will only check for the side squares of side 3 only, you know. This is the main logic part that I have built for this part. Okay, so first I have made this dp. Then what I will do, new minimum side. Okay, why is this new minimum side I have taken new, that is minimum of I comma z? Because let's say, because I'm currently standing at this position where I is equal to 2 and z is equal to 9. Okay, somehow my answer is already 3. I have detected somehow that my answer is already 3. Now if you see clearly, if I will check a square of answer 3 here, it will be something like this, and it will go out of bound. And that's why we have taken that I is equal to 2 and z is equal to, we will take minimum of these two, and we will check that if this minimum is greater than equal to answer. Agar if this is the case, then yes, we can make a square of side answer, else no. And that's why we have done this checking part. Okay, that int new minimum side is equal to minimum I comma z, new min side is greater than equal to answer, and sum. Now we are defining the sum part, that is finding this, finding this one part here. Okay, so what we have done, dp of I z minus dp of I minus answer comma z minus of dp of I z minus answer and plus dp of I minus answer z minus answer. Why? Because this part is removed twice. Okay, and if this sum is less than equal to threshold, then we will increase our side length. We will increase our side length because we don't have to check the side length which we have already captured, है ना? It will if you want to try this question in a different way, you can go for the part like you have already defined a dp array in this part, like I have explained, and then you can go for the each of the side part. Then you will get you will get time limit error in this part. Okay, and as you can see, I have made multiple you know tried in here, and I got this time limited exceeded for this part. If you see, I'll show the code for this part also. That first I was doing this first getting the row sum and matrix sum. Then I was checking for this. So look at the number of loops that I'm making. First I'm checking for of I'm going to I comma j, and then I'm checking the minimum length, and then I'm taking the side from 2 to minimum length, and then I'm taking the one more loop to find out the sum of this square that I have imagined. Okay, so that's why I got this time limited exceeded. So if you don't need to do this kind of mistakes. If you follow this part of solution, I will paste the solution in the description also, so look this, and yep, have a good problem of the day. Yep. See you in the next video.